Primitive obsession is a code smell. Code smells indicate potential problems or a deviation from good programming practices. They suggest a need for investigation and possibly some refactoring of the code. There's a saying, where there's smoke, there's fire, and this serves as a reminder that if there are signs of a problem, it could exist and we may want to investigate. Now the same principle applies to code smells, so in this video we're going to take a look at how to recognize primitive obsession, understand what primitive obsession is trying to tell us, and how to fix it. Primitives are the built-in types within a programming language, such as booleans, integers, strings, floats, and arrays. Obsession is an extreme or unhealthy fixation on something, potentially leading to harm. Kind of like Homer with donuts. Therefore, you could describe a primitive obsession not only as an excessive use of primitive types, but also as an unhealthy dependency that negatively impacts your codebase. The true power of a code smell is recognizing the symptoms. It's like recognizing that smoke may mean fire. There are signs which indicate if our code suffers from primitive obsession. So let's give it a go. Let's examine some code and see if we can identify the signs of primitive obsession. When our code heavily relies on basic data types, it's easy for us to mix up the order of arguments. In this example, both arguments are strings, and if we mix up the order, we're not going to receive any helpful type violations. The email address is a valid string. The ID is also a valid string. If you find yourself mixing up the order of arguments, especially when the same data type represents different ideas, this might be a sign of primitive obsession. We may need to implement additional email address validation in our software, and we may consider adding some simple checks. However, primitive types are unable to encapsulate behavior. Because there is no way to place behavior inside a type, it is forced to exist on the outside. Instead of encapsulating rules and constraints within a specific type representing the concept, they are scattered throughout the codebase whenever the concept is required. Code duplication increases the risk of errors and mistakes by hindering maintainability. If we wanted to add a check for the email's domain, we will need to update every place where similar functionality is needed. Missing somewhere could easily introduce bugs where this check is skipped and our data becomes inconsistent. Primitive obsession can infiltrate our codebase for various reasons. Sometimes it's a deliberate choice after evaluating trade-offs, but often it can be accidental. As our species evolved, our bodies developed ways to save energy. Our brains developed shortcuts they could take when they need to think. One type of shortcut is called cognitive bias, an influence on our decision-making based on personal views and opinions. A form of cognitive bias is the law of the instrument, also known as law of the hammer, Maslow's hammer, or the golden hammer. It's a cognitive bias which illustrates our tendencies to have an over-reliance on familiar tools. You may have heard it in the phrase, if the only tool you have is a hammer, it's tempting to treat everything as if it were a nail. This is our brain taking a shortcut. We prefer to reach for what is familiar and comfortable, even if it's not the best tool for the job. When we are coding, our cognitive bias can manifest as primitive obsession. It's like always using a hammer, sticking to simple data types when a better solution would be to model a new, more specific type. When we define an email address as a string, we allow empty strings, strings larger than 320 characters, strings missing the local and domain parts, or just anything else that isn't a valid email address. We must ask ourselves, are all valid strings also valid email addresses? Since using a string would allow the system to support all these invalid values, it's evident it's not suitable to represent our concept. Therefore, using a string to represent email would be considered primitive obsession. Let's explore how introducing a value object can help us solve these problems. Value objects help avoid issues related to parameter and argument ordering by removing type ambiguity. Previously, both user ID and email were typed as a string, making it possible to accidentally pass one as the other. However, if we were to introduce an email address value object, in order to successfully create an instance of user, we must provide a valid instance of an email address. Value objects resolve our problem with behavior existing outside of our type by encapsulating related behavior and data together. This advantage over primitive types also helps us protect the creation of the type. We could now ensure that our value enforces our business rules and that the type is consistently valid. Value objects eliminate the need to duplicate logic each time a type is used. When we encapsulate state with behavior, we establish a single source of truth. The email address class has a single responsibility: to represent a valid email address. Value objects provide more than just a solution for primitive obsession, and we will explore them fully in a future video. But for primitive obsession, just like all code smells, its usefulness is alerting us to symptoms of a deeper problem, the code equivalent of smoke indicating fire. The next time you find yourself with a primitive type allowing your system to support invalid values, or validation being duplicated across the codebase, or parameters and arguments easily being mixed up, you are recognizing the signs of primitive obsession.
Yeah, probably.